So here we have quite a challenging modeling problem. It says the amount of trout Y in tons. So we want to make note of the units. It's in tons. Caught in the lake from 1995 to 2014 can be modeled by the equation y equals negative 0.08x squared plus 1.6x plus 10, where x is the number of years since 1995. Part A says, when were about 15 tons of trout caught in the lake? And Part B, do you think this model can be used to determine the amount of trout caught in future years? Explain your reasoning. So typically in mathematics, I think I talked about this at the beginning of the year and a little bit throughout, with word problems, you kind of want to just read it once just to read it. And then when you read it again, you want to highlight some important pieces of information to sort of help you deconstruct this problem so that it's easier to solve. So in other words, I know, first of all, that my units have to be in tons, and what y represents, that amount in tons, from 1995 to 2014. This is incredibly important. This is the part that often messes people up. 1995 is my base year. When I'm looking at the number of years since 1995, I have to think of it this way. 95 represents 0, since that's my base year. 1996 is 1 year after. 1997 is 2 years after, etc. So, x is the number of years since 1995. So x represents those numbers, 0 being 1995, 1 being 1996. Does everybody understand that so far? Okay. Well, the other thing that I want to note is that this kind of equation is a quadratic equation, meaning that it takes on a specific shape. We haven't learned how to graph these yet, which we will pretty soon here. But since it's a negative, it's going to have a minimum value, and then it's going to go up. For that second part of the question, the shape is pretty important because it says will it hold up in future years. Well, we have to take into account the fact that it's going to dip down, right? So, it says when were about 15 tons of trout caught in the lake? When you look at this problem, how did you solve it? What did you do in your problem solving process? Yeah, plug in the number of years for y, right? Because that's the amount in tons. 15 tons of trout. So you just plug it in, and now you're trying to find that number of years. So negative 0.08 x squared plus 1.6x plus 10. Well, I need to probably solve this by quadratic formula since it's very difficult. You're dealing with decimals, and that's kind of the thing. When you're dealing with decimals, you want to utilize quadratic formula. So on this next page, that's what they do. The very first thing you have to do before you start listing your A, B, and C is do what with this? Subtract 15, exactly. You cannot use quadratic formula until this equation is set equal to 0. Negative 0.08 x squared plus 1.6x minus 5. Now you can use quadratic formula to solve this. Okay, so that's what they're doing here. We're on this part right now. So now what they're doing is they're plugging in that formula. They have the base formula here, negative b plus or minus square root of b squared minus 4ac all over 2a. And it's just a matter of plugging things in. As long as you can plug things in correctly, then this isn't very difficult from this step forward. Now you are dealing with decimals, and you're dealing with a lot of different numbers, so it's really a test on can you plug in things accurately. Square this, you get 2.56. The product of negative 4 and negative 0.08 and a negative 5 is going to give you still a negative number, negative 1.6. So you end up, when you do quadratic formula with this, which are the exact answers, but we're going to go ahead and approximate. So one of them, and on the test, for some reason, a lot of you, when you wrote this out, you were fine with this one, but then for some reason you didn't do this in the correct order. You switched them around. I don't know why. But things have to be done in the correct order. You see this plus this, and then divide that by negative 0.16. 1.6 minus square root of 0.96, and then divided by negative 0.16. So when they do that, you get 3.9 approximately and 16.1. You have to think about what those represent. About 15 tons of trout were caught in the lake after 4 years in 1999. X is the amount in years. So back in that word problem, when we were thinking about what X and Y represented, we knew that Y was the amount in tons of trout. X is the amount of years after our base year, which is what year? 1995. So 4 years after 1995 is 1999, and then 16 years after is in 2011. So in those 2 years, you had 15 tons of trout that were caught. Part B is a little trickier. It says according to the model, the amount of trout caught after 2020 is negative. So what they're saying here is that if you continue with the amount of years, because the nature of our graph, you're going to end up with negative Y values, which we don't want to catch. Well, we can't catch negative trout, right? So in this case, the model will not hold for future years. They tested a few, and then in 2020 it turns out to be negative. But you could kind of get that from the nature of the graph. I know this is tricky. I wouldn't ask you this on a test, but I just wanted you to think about what to do on a modeling problem like this. Do you have any questions? Okay. Now, this next slide is a big one. We're continuing 10-1, so you might want to take out your notes. You do not have to write all of this down. You can if you want to. You can just write the page number to look back at this. You can just listen if you want to. But we are going to talk about transformations. So as I mentioned before, the good thing about talking about transformations at this stage in the game is that we've already talked about them so many times. We talked about them with absolute value functions, which is the first time really we were introduced to the transformations, and it was tough. We talked about them again with exponential functions, and now we're going to talk about them with square root functions, and we'll talk about them again with parabolas. The nice thing is they're all very similar. The types of transformations are all very similar. So one of the things that I wish your book did, that they don't do on this slide, is give you the general form. So the general form of a square root function is f of x or y equals a times the square root of x minus h plus k. We talked about this already a little bit yesterday. We're going to talk about it again today. So yesterday we focused on finding the domain and range of square root functions, and we're going to look and see how each little piece of the square root function, the a, the h, and the k, affect our graph in terms of movements and stretches and compressions or shrinks. Okay? So the first one is a horizontal translation. As before, when we've had h's in the past, it is attached to the x value, and it's always the opposite side. So if you see an x minus an h, so in this case, x minus a 2, that's going to be the movement in the opposite direction. So rather than move 2 to the left, it's going to move 2 to the right. Same thing with the plus 3. Rather than move 3 to the left, it's going to move 3 to the right. Rather than move 3 to the right, it's going to move 3 to the left. So it's always the opposite direction. And that's only with the h, with this x minus h part. Same thing as before. Same thing with absolute value functions. Same thing with exponential functions. And it's going to be the same thing when we talk about parabola. Vertical translations. Now, vertical translations, that's this outside plus k value. That could be positive or negative, and that affects movement up or down. Our vertical movement, right, along the y-axis here. So plus 7 moves our graph up 7 units. Minus 1 moves it down 1 unit. That has not changed. The big thing that you want to remember with vertical movements is that it affects our range. So with our parent function, when we have y equals the absolute value of x, or f of x equals the absolute value of x, our parent function, we found our domain yesterday, and we said our domain has to be greater than or equal to 0. As soon as you attach a number to the outside, that's not going to affect your domain, that's going to affect your range. So if I attach a plus 1, now all of a sudden my graph moves up, this stays the same, but my y is now greater than or equal to 1. Do you have questions about vertical translation and how that affects your range? So it doesn't matter how complicated I make this. So if I say y equals negative 5 times the square root of x plus 4, if I don't attach anything to the outside of this, my range is still going to be y greater than or equal to 0. It's only when I attach something to the outside where this range changes. Reflections. Just like before, we're going to look at reflections. Now, again, there are parts of the reflection and the strengths and stretches that we're not going to address because you're going to see them again in Algebra 2, and if you teach calculus, you'll see them again in calculus. But with us, in this part of our mathematical journey, we're just going to look at reflections over the x-axis. So what do those look like? Well, that's just if it's our a value is negative. So if what's on the outside is a negative here, then I'm going to be reflected about the x-axis or over the x-axis, depending on your teacher. I might say about the x-axis or over the x-axis, but you'll be reflected over the x-axis. That means that if your entire function, you have a negative as an a value, that affects your entire function, that reflects it. That's why you see this here. Stretches and shrinks. Okay, graph stretches away from or towards the x-axis here. We're not going to deal with horizontal stretches or shrinks, so we're just going to skip right on over that and go to vertical stretches or shrinks. The vertical stretches or shrinks take place on the outside here. So, if I have a negative, let's say I have a negative 4 times the square root of x minus 4 plus 4. Y equals that. This negative is going to reflect it. This is going to stretch it. Okay? This is going to move it to the right 4 units, and this is going to move it up 4 units. Does that all make sense to you? Okay, so none of that has changed. If you have questions about that before I show you a visual about what that looks like. Are you still writing stuff down, or are you good? Okay. Alright, we're going to take a look at each of these different scenarios here. A being that value in front of the square root, h being the value here, and k there. So I want to give you a better visual of what I'm talking about in the last slide. So let me pull that up here. So what I've done is I've taken this general formula and I've added sliders to this Desmos. So what we're going to see is what happens here. Now I made my A1. So the first situation is, well, if A is 1, it's not going to stretch or compress. Remember, we can say shrink if we don't want to say compress. It's not going to stretch or shrink at all if A is 1. So I didn't put that in there. Now, what happens when A is less than 0? That's the first situation. So I'm going to take my slider. what's happening? What happened to it? It flipped. So whenever it's a negative value, it flips, right? So we see that it's just getting smaller and smaller, and then it's just going to flip. What happens when a is 0? Yeah, it's a straight line, depending on what k is, right? If k is 4, y equals 4, we know that that's just a horizontal line. So how do you want to answer this? Well, when a is less than 0, my graph reflects over that x-axis. Okay. We talked about stretches and shrinks. If it's in between 0 and 1, so in between 0 and 1, what's happening? It's getting closer and closer to what axis? My what axis? My x-axis. So here I am, and I should have put in between 0 and 1 on there. So if a is in between 0 and 1. If a is in between 0 and 1, it's getting closer and closer to my x-axis. It's compressing or shrinking. So when a is in between 0 and 1, it shrinks towards my x-axis. When it's greater than 1, what's happening to it? Yeah, it's getting closer to my y-axis or stretching. Remember the weights? And I had to stretch. So it's a stretch. So anytime it's greater than 1, it's going to be a vertical stretch towards my y-axis. This is going to keep stretching closer and closer to my y-axis. Let me make it 1 again. Okay. Do you have any questions about the stretches, shrinks, and reflections? Okay, remind me again. When does it stretch? When it's greater than 1. When does it shrink? In between 0 and 1. When does it reflect? When it's less than 1. Perfect. Okay, now let's see. Okay, right now if that's 0, that means it's not moving left or right at all. If it's positive, what's happening? Right, it's moving, right? So if I'm subtracting a 4.6, it's going to move to the right 4.6. Does that make sense? Because this is a minus sign here. If I have a 5, that means I have x minus 5, it's going to move to the right 5 units. If I go the other direction, here, it's moving to the left. Now notice that, let's go to a whole number here, -2. This isn't going to show up as -2 here because I have a minus sign. What's this going to look like? X plus 2. If it's x plus 2, it's going to move to the left 2. Does that make sense? If my h is -2, I already have a negative, so those negatives cancel out. Okay. Do you have any questions about that? And then lastly, with our visual, the k. The k affects our range. So as soon as I make that k positive greater than 0, then it's going to move upwards. It's going to affect my range. What's my range here? Y is what? Y is... Don't say it all at once. Greater than or equal to 4. Right. My graph starts here and it shoots upward, right? So it's 4 and above. My graph's not down here at all. Okay, so it's not affecting my range below 4. So my range is 4 and above. Y is greater than or equal to 4. When I go negative, it just moves it down. So what's my range? What's my range now? greater than or equal to -5. Right. Visually here, my graph is at -5 and then it goes upwards. Okay. Do you have any questions about the transformations at all? No questions? Okay, great. We're almost done. Okay, I'm going to tackle this example 3. Comparing graphs of square root functions. Compare the graph g of x equals negative square root of x minus 2. Compare it to the parent function f of x equals the square root of x. Our parent function is easy. It's our base function without any transformations. I'm just going to go ahead and graph that on my 10 by 10 xy axis. All I'm going to do, of course, is just plug in values and plot those points. It's not any more complicated than that. What's my domain? Remember, I have to find my domain first to find my x values. My domain is x's greater than or equal to 0. Why is that my domain? I can't have a negative. So let's pick a couple positive values. 0, 1, 2. Well, let's not do 2 because that's not perfect square. Let's do 4. Looking at my parent function, obviously values, or square root of 0 is 0, square root of 1 is 1, square root of 4 is 2. I'm going to plot those points. 0, 0, 1, 1, 4, 1, 2. I'm going to connect them. Please connect them. And then I'm going to draw my arrow. Okay, I'm going to look at the next graph and I'm going to do the same thing. Now you may want to plot more points here. You could do 9 and 3 if you want to. So just one other thing. Let me plot this. So make sure it's going up correctly. 0, 0, 1, 1, 4, 2, 1, 3. I plotted another point so that I knew it was going that way rather than that way. Does that make sense? So, more points the better. You don't have to plot by million, but just enough. Okay, now, the parent function. First of all, what's happening in terms of transformations? Not to my parent function, but to the g of x function. It's being reflected over the x-axis. What else? Yeah, it's being moved to the right too. Now, all you have to do is find your domain again. X minus 2 is greater than or equal to 0. Add 2. X is greater than or equal to 2. So pick 2. Plug in 2. When you plug into the g of x, what do you get for g of 2? What's the value of g of 2? Yeah, right. 2 minus 2 is 0. Square root of 0 is 0. Negative 0 we can't have, so it's just 0. Okay, let's do 3. What is g of 3? Yeah, negative 1. 3 minus 2 is 1. Square root of 1 is 1. And then you have a negative on the outside, so you have negative 1. Let's not do 4 because I'm going to get a decimal. Should we do 5? Do 6? If I plug in 6, 6 minus 2 is 4. Square root of 4 is 2. Then I have a negative, so negative 2. Let's do one more crooked measure. What's the other one? 11. Okay. I do 11. 11 minus 2 is 9. Square root of 9 is 3. Then I have a negative. So I'm just going to plot those points. And then I have my graph. 2, 0, 3, negative 1, 6, negative 2. And then I have 11, negative 3. So it's just moved over and reflected. Do you have any questions? Any at all? Okay. I will give you 3 minutes to just do whatever you want. Square root function. I'm going to compare it to my parent function. So I'm just going to plot the same points that I did in the last slide. 0, 1, 4, 9, 0, 1, 2, 3. So my parent function, f of x equals the square root of x. So 0, 0, 1, 9, 4, 2, 9, 3. Describe the transformations from the graph of the parent function to the graph of g and then graph it. Well, what transformations are taking place? What's one of them? Reflection about the what axis? It is important that you specify that. There's a horizontal translation. Yep. How many units and what direction? Yeah. Horizontal translation. 3 units, right? And then we have, what else? Vertical translation. 2 units, what direction? Down. And what's that 2 in front do? Stretch. Vertical stretch by a factor of 2. Excellent. Okay, so on the homework, on this part, that's what it's going to ask you to do. You do this, you list the transformations, and then you just plot points. Find the domain first. What's your domain? Well, I have to do x minus 3 is greater than or equal to 0. X is greater than or equal to 3. That's my domain. Okay? So, just plot points. Plot 3. When I plug in 3, what do I get? 3 minus 3 is 0. 0 times negative 2 is 0. 0 minus 2 is negative 2. Okay. And then, let's plot 4. 4 minus 3 is 1. Square root of 1 is 1. Negative 2 times 1 is negative 2. Negative 2 minus 2 is 4. What's another good one? Another good x value. 7. Yep, 7 is great. That's what I think too. Okay, when I plug in 7, 7, 6, 5, 4, I get a perfect square. Square root of 4 is 2. 2 times negative 2 is negative 4. Negative 4 minus 2 is with, we'll plot those three, see if that's good enough. Let's see. So, 3, -2, 4, -4, and 7, -6. Okay. That's my graph. Notice my starting point's right here. It doesn't have to always come from the origin. I know those are kind of tricky, but doable, right? On the quiz, I'm thinking the majority of it's going to be multiple choice, and then you'll probably have one like this. So, that you can show me you can graph complicated transfer function. And that's pretty much it for today.